Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel. This episode is brought to you by viewers like you, so head over to patreon.com/simpleelectronics if you want to support the show. More about that later, because right now I've got a very special guest. A couple episodes ago, I was going through some Hackaday projects and I found a really awesome project, which I'll let him explain. But with me today, I've got Chris from the electromechanical analog digital clock project on Hackaday. How are you, Chris?
Oh, I'm fine. Hi, Dan.
Nice to meet you. We just started chatting a few minutes ago, and I feel like there's going to be a lot to uncover about you and your projects.
Yeah, I hope that you find my project interesting. And it was always fun to build these projects.
So not just me, but even my viewers, if you read the comments on that episode, they're really interested in getting some more information about it. But let's start from the very beginning. Just maybe if you can give us a little brief about who you are and what you do.
Yeah, I'm Chris. I'm from Germany, south of Germany. In normal life, I work as a project manager at a big company here in Germany for penetration tests. And my hobby is doing electronics, and I want to do nice electronics that look good, and so that even, the women's acceptance factor must be quite good, that I am allowed to put it somewhere in the house.
Very nice. Actually, your electromechanical analog digital clock, maybe I won't say it the whole way through every time. It's giving me a little bit of DIY Perks vibes. Do you know the YouTube channel DIY Perks?
No.
Oh, is it DIY Perks? I forget. He's the guy who made a giant iPhone. He made a computer hidden into a desk. But anyways, his use of like wood and brass, it really sort of, your project gave me a little bit of that vibe, if that makes any sense.
Yeah. Why did I choose wood and brass? It was just it was a development to make to make it fit nice into the house, to place it somewhere, to make electronics in a way that it's looking good.
For sure, absolutely. That's not my domain, so I'm glad someone else is doing it like you. But let's get started though, because this clock, first of all, it caught my attention. Because the sort of like the heart of a clock is you need a 60 hertz pulse. You need some way to keep time, and then sort of the rest of the mechanism revolves around that. Now, most wristwatches, they'll use a quartz crystal or some sort of a balance wheel, an escapement movement, whatever. You chose none of these things. What did you choose to keep to get the clock pulse, so to speak?
Yeah, I choose that 200 stepper motor. To be honest, I found a similar project that used the stepper motor for a 1 second pulse in Hackaday, or some other project. He did some, it was totally mechanical. He used the stepper motor as a seconds wheel, and then the whole clock was driven by that. But I thought about, hey, I could use it as a pulse sort for 1 second pulses. And that's why I chose it.
But it's not quite that simple, because the electricity here in North America runs on 60 hertz, right? Which would be exactly perfect for a second. But over in Europe, it's 50 hertz. So you're not just taking the straight pulse. You have to deal with it somehow to end up with 60 seconds, correct?
Yeah, it's because the 50 hertz, if you have a 200 and stepper motor with 50 hertz, you get one revolve in 1 second with 200 and steps.
Oh, I see. So your stepper motor is going fast then.
Yeah, once a second, one revolve.
Okay, so here we go. Now I'm looking at the picture, and I'm going to try to paint a word picture for the some of my audience are just audio listeners. And so you have on a green piece of PCB suspended by 4 springs, you have the stepper motor sitting there, and there is a black arm on it that looks a little bit like a Batman symbol, to be honest. It's kind of flared out on both ends. And so that black arm is spinning. So what How are you getting the pulse to your circuitry from that black arm?
It's a simple light barrier there. This on this black arm is a small how could I say it? Piece of it's a 3D printed part, and it goes through a small light barrier. I don't know what the correct English word for it is. In Germany, it's called Gabellichtschranke.
Oh boy. Yeah, Germans have a poetic way with words, right? Because sometimes the words are very, very concise, and sometimes they're just like 8 words mashed together. But yeah, this is just basically an optocoupler. An optocoupler. Yeah, essentially. So there's just if people can picture 2 pillars, and there's a infrared LED on one pillar, and on the other pillar there is a infrared light detector. Usually it's like another type of LED just tuned for grabbing light instead. And then there's like a flag on the arm, and the flag will block off the light detector from the light emitter, and that will give you your pulse. Correct? Am I correct in all this?
Yes, totally correct. Yeah.
And so what are the springs for? I mean, don't forget, I read the article, but I want my listeners to hear it from you.
A stepper motor is loud, and I try to get it as silent as possible. And it's, I thought about the springs. How can I get it that it's floating, not decoupled from the base? And so I came up with the springs. It's kind of working, yes. But the 50 hertz hum is annoying.
Yeah, no kidding. I used to have aquariums going here with fish in them, and I would use a pump, an air pump to run a filter, and the air pump would vibrate at 60 hertz because it was the simplest way. Had a little like a swing arm mechanism that essentially was an electromagnet. And in order to quiet it down, I went and I raided my wife's hair elastic stash, and I had suspended it from her hair elastics. So this is kind of reminding me of that kind of problem solving right there.
Yeah, it was. I also tried to use not a stepper motor, but a synchron motor. There are no motors in for clocks for 50 hertz or 60 hertz, but they're also so loud, and it does not matter. To be honest, the clock is not switched on because of that 50 hertz hum.
Oh no, this is we should have kept this for the end. We should have teased it.
Okay, sorry.
No big deal. No editing here because editor Dan will have to do all the work. Okay, so let's keep going then. So you're grabbing pulses from a opto sensor. But then that's not it. Like, you're not taking that directly. You have to treat the data, right? You have to grab those pulses and you have to condition them. So tell me about the next stage in the clock.
Yeah, the next stage is simple. A small circuitry that takes the pulse from the light barrier and makes a pulse that is then fed to the stages for seconds, minutes, hours. And there I have some CD4040 counter, one for the seconds that is reset after 60 pulses and fed through the next stage, one for the minutes and one for the hours. So it's quite simple.
Well, I mean, it does sound simple, but you do have to explain as well that these are not like dead bug chips. Each stage has its own PCB, correct?
Yes.
And so
that was also something I wanted to thought about. How can I make it also beautiful and keep it small? And that's why I made it in equal sized PCBs, each of the steps. So the pulse generator, the seconds, the minutes, and the hours. And then also in the bottom, the power supply, but that is much bigger. And all PCBs are looking the same. They have only minor changes because 2 of these have to reset after 60 steps and one after 24 steps.
And then you mounted all the PCBs. You stacked them up on the rightmost side of the clock on these brass standoffs. Are these off-the-shelf brass standoffs, or did you cut your own piece of brass pipe?
I cut my own piece of brass pipe. I went to the store and bought 1 meter of, I think it's 6 millimeter brass pipe. Cut it, and you see, brass is so easy to handle. You can cut it easily, can solder it easily. It's perfect for that.
Yeah, it's really nice. And then towards the front of the stack, there's some LEDs. So I'm assuming that you're counting up from 0 to 60 in binary. Am I correct?
Yeah. Yeah, that's it.
So the first stage on the very top, there's only a single LED. What's the first stage on the very top?
That's the 1 second pulse. That's directly from the, if the light barrier is blocked, then the LED lights up and the pulse is created.
And is it triggering like a Schmidt trigger or anything like that? Or is it just, it just lights the LED?
No, there's a small circuit on it. And to be honest, I don't know what circuit it is at the moment.
No stress. Don't worry. The project is impressive enough. I'm just trying to squeeze some details out of you. And then, so the next stage down, that one counts the 60 seconds.
Yes.
And the next stage down, it counts the 60 minutes. And then the next stage down,
24 hours.
So there's five. There's 5 LEDs on that one. So yep. 5 to the power of 2 makes 25. Mm-hmm. So you can display up to 25 hours if you really wanted to. Yeah. And then at the bottom, I see 3 LEDs. What do those do?
These 3 are only for the power supply, for the plus 12, minus 12, and 5 volts.
Okay.
When I remember correct, yeah.
What does this get powered by? Is this plugged in? Well, it has to be plugged into the mains, right? Because you need the 50 hertz.
Yes, it's plugged into the mains.
There we go. All right. And moving on now, because so that is kind of like the mechanics of how the clock works. How does it display its time now? Because I think this is also a very attention-grabbing feature.
That was, I would say, the start of this project. I was on the big auction house, you all know, I think, on eBay, and I always search for this and that and for moving coil meters. And then I found these big 2 moving coil meters here in Germany for €1 each.
Oh, wow.
And I thought, I buy them and see what I can do with them.
For sure. Buy first and think later.
Yeah. I can use it sometimes. And yeah, and that was the start of this project. I had these moving coil meters, and the first one is for the hours, the next one is for the minutes. Yeah, and for the seconds, I bought some small one from big company, just to show the seconds also.
So the little tiny one below your stepper motor, that one actually moves with the seconds, so it takes a minute to fill up and then empty out?
Mm-hmm. Yes.
Oh, that's cool. So then how do you go from your counting circuitry to, I'm assuming if it's a balancing coil meter, you need to current control it to give it the correct time, correct?
Current, it's voltage controlled.
Oh, it's voltage controlled. Okay, that makes sense. So there must be some, like a 1 ohm coil or something like that. So it's very simple.
Yeah, it's very simple. I had to be honest, I had to modify the moving coil instruments to match that they work between 0 and 5 volts, because the original one was up to 10 volts. Replaced one resistor in it. Yeah, they are driven by some digital analog converters. At first, I thought I will do it with some R2R ladder, but that it would have broken everything. It would be so big if you want to have the R2R ladder to convert digital to analog. So I used some DAC 0808 and a simple small operational amplifier to get my voltage.
So that's really cool. And then you sat this whole thing on on 2 pieces of wood, and they look like they were stained, and maybe you put some feet underneath it, and then you have yourself an art piece, but a functional art piece.
Yep. The wood was some scrap wood from our, that I found in the basement somewhere. Was left over from, I don't know what project.
So tell me, what do you think the total cost of this project was, because I do see, you made 1, 2, 3, 4, 5, 6 custom PCBs. You bought the meters. Mind you, 2 of them were very inexpensive. How much do you think this cost you to put together? Ballpark is fine.
€100? Oh, don't know.
Geez, that's
Not
a lot
that
of money.
much.
€100 here in Canada is like almost, it's probably like $165 or something like that, $180.
Yeah, the PCBs, I let them, I did it not produced these not myself. I stopped etching my own PCBs. So I put it somewhere to be produced, and they produced not only one PCBs, but you get more, but it's less effort than etching PCBs on your own.
Oh yeah, for sure. And a lot cleaner as well.
I think, yeah, €100 is okay, I think. And the time is more important. I do not know how much time I've needed to build it.
That's going to be the next question. But now, since you've answered that, what about if a viewer of this podcast and the previous podcast goes onto Hackaday, takes a look at your clock, says, I must have it. Is this something that is now sentimental to you because you've built this project? Or is this because it's not plugged in and it's not very practical? Is this something you would be willing to part with?
Nope. And to be honest, it's not perfect. I always thought about building the circuits again because I forgot to debounce the buttons to set the clock time.
Oh,
yeah.
I see.
So it's a more a guessing game. How many really minutes are forwarded if I press the button 1 time because it's bouncing.
Well, let me let you into a secret. Because it moved from pure electronics into art, it doesn't have to be perfect.
Yeah. But, with my next project I'm currently on, I practice a lot surface-mounted device soldering. So I could make it better now because I could move from through-hole components to SMD components and have more space on the PCBs but that's something when I'm retired.
Which is when? You don't sound too old to me.
I'm 54 years old.
Oh, really? Okay, you don't sound a day over 38.
Oh, thank you.
You've got some stuff to answer for, though, because the picture of your clock is sitting on a bookshelf, one of those ones with the square openings, and it is just surrounded by nerd culture. Is this your influence, or is this your partner's influence? Because you said it needed, your partner's approval to be put on the shelf.
It's my influence. That's definitely. So the shelf disappeared now. It's now replaced by some with glass. It's a vitrine. I don't know the English word. Because of the dust. And now it's all inside something that the dust does not collect so much dust, because you see the eagle that is on the left is very hard to keep clean, and also the Enterprise on the right.
Yeah, so just for those listening to the audio version, you should go check the article in Hackaday, but I also have eagle eyes, so he has more than that to answer for. So on the left, you've got a spacecraft that is, the top of it is mostly scaffolding. Now, you're going to have to forgive me. I'm not sure where this spacecraft comes from. The one on the left?
Space 1999.
Oh, okay.
Space 1999, or in Germany it was Moonbase Alpha 1.
Oh, I've heard that one. And then on the right, it looks like it's the original Enterprise from the original series.
Of course, it's the original one.
Directly below the clock, though, I have eagle eyes, so I can see 2 wings from an X-Wing fighter from Star Wars.
But then Earth, X-Wing fighter.
But then all the way on the left, there's some sort of retro, I don't know if it's a console or something, but there's looks like almost like a typewriter keyboard, and then there's 2 big red keys. I don't recognize it. What's this from?
It's a Fazit 16 mechanical tabletop calculator. It can, you know some of these calculators where you have now I don't know the English word, a kurbel. You have to rotate it.
Oh, a Curdy calculator, I think in English. Oh, it's like a cylinder that you have to rotate, and then there's a little handle that you have to crank.
Yeah, a crank. Yes, crank. That's a correct word.
Oh, there we go.
In Germany, it's eine Sprossenradrechenmaschine. It's a totally mechanical calculator that can add, subtract, and if you know how, you can also make multiplication and division.
Which is just iterations on addition, right? Like multiplication is just addition multiple times over. That's how computers still do it, I believe.
Yeah.
Just very, very quickly.
Yeah. And I got it from my grandfather and it's still sitting there. I always like mechanical calculators. I have a second one, and in the basement there is still to repair a mechanical cash register.
So at what point is it time to make a little video, on a YouTube channel to show people, share your passions? Because I'm sure there is like a niche world of people who love mechanical calculators and would like to see the ones in your collection, or, this, I'll tell you right now, if you would have made a video in the style of like DIY Perks or any of those YouTubers about your clock, you're looking at 200,000 views, sort of minimum. Is there some sort of reluctancy to make videos? Is it just not your jam? Because you did share it. I mean, you put it on Hackaday.
I think to make videos is not my thing. You see, I love to make photographs. I have expensive photos here, cameras, but not for videos. Perhaps I'm too old for that.
Well, I mean, I'll say you're never too old, but I will say it's fair enough that if it's not your modality, it's not your modality. But just speaking to you here, I can just tell that a ton of at least my viewers would be really interested in the stuff that you're interested in. So just something to keep in mind. You're not alone in your nerding out.
Yeah. Okay. But my mechanical calculators, I have also one in the basement also that is not working correct. Perhaps your listeners have some information about a Multa 32 mechanical calculator, because it's not working correct and you do not get any service information about that because it's too old.
Ooh, and you've looked through YouTube, because I'm sure there's someone.
Yeah.
Okay. Wow.
I have found someone in YouTube who has a working one, but yeah, it's working, and you see that thing is so fully packed with metal levers and rotating, and I don't know where it's stuck.
Well, I managed to reach out to Chris via his Hackaday account because I didn't find any more social media for you. You have a GitHub and a Hackaday, as far as I know. So if someone has any idea about repairing or diagnosing mechanical calculators, please reach out to Chris, via his Hackaday or via his, I don't know, can you reach out via GitHub? I don't know. GitHub scares me a little.
Yeah, but you cannot live without GitHub.
No, that's true. Actually, to be honest, at this point, I find it much simpler to ask ChatGPT to make some code for me. I am not a coder. It does not come easy to me. So if I can't type it up myself, like you should know how much trouble I had the first time that I went to someone's GitHub and tried to get software off of it. If it's one page, I can do that. Right click, select all, paste it into my IDE, we're good. But if it's like a multi-level project, it's not for me. It's not a skill I've worked on yet.
I use it really for versioning of my software. I also in this project there is no software because it's plain hardware, but I also built a word clock that is nowhere documented, and the software for the ESP32 is in the GitHub, or my current project, the Game of Life, is also in GitHub with some libraries for the SPI communication for the LED controllers and so. So I use it as a version control system as it is meant to be.
Makes sense. So let's jump over to that new project. So first of all, for those, because I just learned this only a couple of years ago, can you just explain, first of all, what the Game of Life is? What's Conway's Game of Life?
Conway's game of life is cell automation. Automat with very simple rules. You have a flat surface with cells, squares. Each cell has up to 8 neighbors, and the count of neighbors tells if a dead cell a cell keeps living, or a cell is dying. Very easy. That's it.
Yeah. And there are starting patterns that sort of like appear at the start of a game. And then the game, it's not a game per se. It goes itself. It functions itself. Correct. There's no.
That's it.
Yeah. So.
And if you look at Game of Life, there is people are mad what they make with Game of Life. You see, they also make clocks inside Game of Life, and I think there are also some people that build a computer with Game of Life.
Yeah, it's an interesting thing because there are certain like patterns of like in some cases it's either pixels or LEDs or whatever, like the cells. There are patterns that have known behaviors because if it has a certain pattern, that means it has a certain amount of neighbors. And there's some patterns that go diagonally, down to the right, and some down to the left, some go up, some oscillate. So it's a little bit, it's crude. You can make a crude computer out of this. But I think you started by saying you have like a plane. You said, it's flat. Yours isn't flat. What is your project? Why is your project special?
It's a cube with 4 planes all connected together. At first, I wanted to make a globe, but on a globe, I had that problem. Perhaps if you know mathematicians, how do you evenly place cells on a globe so that every cell has 8 neighbors? So I did not find a solution for that. So I kept with a cube, and each side has 16 times 16 LEDs on it, and it's an infinite surface then.
And so since you have 16 by 16, that's 256 LEDs per face of the cube. A cube has 6 faces, so 256 by 6. So every time you want to build this project, let's say you had to restart, you'd have to repurchase 1,536 LEDs.
Yeah, and you have to solder them. That's why I learned how to solder SMD. I had to buy many things for my workshop in the basement. A hot plate, a hot air soldering iron. I need some magnifying glasses, tweezers, and but it worked. I soldered 1,536 LEDs.
Were any of them defective, or did you get them all from like a good supplier?
I get them all from a good supplier.
Oh, damn you. Yeah, it's true. You were saying that you have a good job earlier. It makes sense. I buy my LEDs in bulk from China from the cheapest supplier. What size LEDs did you use?
0805, I think.
Okay, 0805, that's good. I just finished a project today on my live stream, and I was using 0603, and I got so used to basically working with a camera between me and my work that I was able to hand solder my 0603 LEDs from about 30 centimeters away. So I'm starting to get good at that. So you used 0805, which is actually for hobbyists, I would recommend. The 0603 is starting to get a little small. It's a little hard to hang on to. And then I'm guessing you used a solder stencil and then squeegeed paste over it?
Yep.
How big are the sides on this?
Let's think about it. It's 8 centimeters.
Okay.
Yeah.
So let me just convert this to inches, because I have some viewers in in the US or Liberia or Myanmar. So it's 3.14 inches. It's pi inches by pi inches. That is brilliant. By accident, probably, but still brilliant.
Yes.
So, okay, so let's give a visual for the viewers here. So what I'm looking at is there's a piece of wood, and there there is what looks like a Arduino Uno R3 sitting
Yep.
on this piece of wood. And then there looks like maybe a piece of brass going straight up. And then you have your cube sitting with, like, the piece of brass is going through one of the corners. And so the cube is standing up, as if it could never fall, right? It's sitting right on its corner. And then, all the sides are enclosed. The only open space I see is that each one of your 6 sides of your cube has sort of like rounded corners or like cutout corners. And so essentially every corner of the cube has a notch that you can sort of look in, and every side of the, like every maybe not side and maybe not corner, but where 2 planes meet in the middle, there are notches cut out there. So what's the internal structure look like? Because I can see that you do have 4 Phillips screws per quarter of every face. This is really hard to explain, guys. You need to go onto Hackaday and take a look at it. But what does it look like inside?
Inside is 3D printed panels where all these PCBs are mounted on, and these panels are then centrally they click into each other and have some support cross in the middle where they are screwed on. I don't know how to explain. It was also an iterative development of the internal structure. The first one was a simple fail. It did not work. I could not wire it, everything, when it's connected, everything, and screwed together. So I had to rebuild it, and I made some plates or panels that click into each other and are fixed with a big cross in the middle of this cube that is hidden inside.
For those of you not going to Hackaday to take a look, you are missing out. It is absolute beauty and chaos at the exact same time on the inside of this cube. It is insane. So I mean, I think you've explained it as well as it gets, but it doesn't mean that it's a simple task. I mean, it is incredibly complicated, but it looks like you ended up with something that is actually fairly stable. Like, it looks pretty strong. Would you say it's strong?
Yep, it's strong, yeah.
So,
but I have to disassemble everything because, as I said, I want to have it perfect. And if you look at the first picture that you see, on the edges, there is a small gap, and that gap has to disappear.
Oh my God. This is insane. But you're not redoing the panels, so the outside panels are final, correct?
No, that are final, but the inside has to be... there are some spacers, and these spacers have to be reduced by 1.5 millimeters, and then everything should be okay.
So how are you... Oh, wait. Every side is 4 individual PCBs? I thought every side was... It looked like one sheet of 4 quarters, but I see. So you actually have 8x8 matrices that are independent of each other. And then I guess in software, you have to define where they are.
Mm-hmm.
Oh my God, this is complicated.
It's a Max 7219
CWG
matrix controllers.
Yeah. Wow. That is crazy. Okay, so I'm looking at the back of a board here, and you have load, LOAD, ground, digital in, clock, 5 volts, and D out. So I understand what the 5 volts and ground does. I know what the digital in and digital out does, and I know what the clock does. What does the load do?
It's depending on the datasheet you're reading, it's something like chip select.
Oh.
So if it goes on the rising edge, so you pull it down, then you do via SPI send all the data. All these chips are daisy chained. And if all the data is sent, when the load gets high on the on rising edge, then the sent data is moved to the LEDs.
This is incredibly complicated. This gives me the same energy as as a person in their basement who has designed a full scale train set. Like, it's just the complexity level here is incredibly high. Like, let's say, like, how long ago did you start this project? You posted it last month, but how long ago did you start?
Half a year ago, I think. It was always some more thinking about it, testing it, buying some test equipment, putting it together on a breadboard, playing here, playing there. I had to write my own library that can handle up to 24 of these controllers. And my goal was it should run with the simplest Arduino I can get. So I have not that much storage or RAM to store it. So one LED is only 1 bit.
Which makes sense. I guess that's the bare minimum you would need.
Yeah. At first I thought about using NeoPixels, but I made some projects with NeoPixels and with an Arduino, and it took not very much time, and the Arduino was out of memory.
Yeah, I think it's time for projects that are this complicated to move forward, away from the old school Arduinos and start using things like the RP2040 or even the 2350, because they're way more capable chips. And if you buy them from like generic suppliers on Amazon or from China, they're like the same price or cheaper than even the Arduino clone boards. Have you had any experience with the RP2040?
Not up to now. No, I do many things with the ESP32. Also some ESP Home with a Home Assistant integration, and but not with the Raspberry products. And for this, I wanted to make it as easy as possible with minimal effort or minimal controller I could get that can handle SPI communication.
Which is fair enough. So you did the electronics part, right? You said you had to prototype on breadboard. How do you go from, okay, the electronics work, now I have to build the physical layout? What's your plan of attack? Like, it just seems to me like that would be a massive problem to undertake, getting this cube to essentially float on a single post and be robust and support everything. So what was the process like for you?
First, I designed the PCBs for the auto, for all the LEDs that have a minimal gap also on the edges. And then, when designing the PCBs, I also thought about how can I fix it on some support structure. And that's why these 4 holes are there. Yeah, and then I started and thinking about how can I put it all together. The first part was a real fail because it was not possible to wire everything if the PCBs are connected to the support structure. And then I thought about what can I do next. And it's some trial and error and thinking about that. And if you see, hey, that would work. Yeah, I have a 3D printer here and I print some example, try if it works, it clicks, and that's it. And then think about, okay, that clicks, and how can I really fix everything? And then I came up with the big cross in the middle with the brass tubes and some threaded inserts. And it worked. It was good that the second try worked. It could also have been that the second try was also a fail.
It is incredibly impressive. I just want to be clear. Like, what kind of software did you use for this? So first of all, like, I use KiCad myself. What kind of CAD package do you use to make your PCBs?
It's Target 3001, I think it's named. It's from a German company from Ingenieurbüro Friedrich. It's I selected it after Eagle was discontinued.
Okay. Oh, is Eagle discontinued for real? I didn't even know that.
But no, I switched from Eagle. Now I know it from Eagle because Eagle in the free version had the limitation of the size of the PCB you are developing.
Oh, yeah.
And I had to make a small PCB for telescope mount controller that had also a big display. And the display was as big as a maximum PCB size of Eagle in the free version.
Gotcha.
And that version is not limited on the PCB size, but on number of components. So I decided to use it, and hey, when you get used to a program and you know how to use it, you stay with it.
Oh, for sure. Because the barrier already, like it's effort to make a project. And then if you have to spend some of that effort to just learn a new piece of software, it just makes the process so much more grueling.
And for the support structure, I have Solid Edge for 3D constructions.
Okay, interesting. And then you sent it off to a PCB manufacturer. Did you use overseas or did you use something local?
Overseas.
Okay. And then was there any problems with the process of learning to solder SMD at home?
I looked up some videos on how to solder it, and I read about things to remember. For example, the airflow of the hot air gun. And then I tried and with some spare PCBs, and yeah, the first one I blew away the LEDs because the airflow was too high.
Yep.
And I really learned to use a hot plate if it's possible, and then it's so easy. You just place it on your solder paste, place it on the hot plate, switch it on, wait a minute, and everything is soldered.
Yeah, it's great. Then you have to be patient, and you don't go poking at your components before your solder is completely solidified again.
Yep. Mm-hmm.
Yeah, it's really cool stuff. But yours is if I'm not mistaken, these are double-sided loads, right?
Yeah.
So did you do one side with the hot plate and the other side with the hot air?
Yes, that's it. Correct. So the LEDs were with the hot plate, and the components on the other side are with the hot air.
That's pretty ambitious to have SMD parts on both sides, because if you screw up, you can make the LEDs fall off the other side if you're too slow with the hot air.
Yeah, I placed the PCBs on cold metal plate, and it worked that the LEDs were not desoldered.
Excellent. And so once you tighten up the frame, once you get everything a little smaller and make it perfect, is the project at that point, is it done, or are you already thinking of sort of like another iteration, another thing you want to add to it?
No, I think it's done then. It gets also some controls for brightness and density of the starting pattern. That's also only some random pattern. And it all will sit below a glass globe.
Awesome.
Yeah, but it will be then. At first, the first thing I wanted to do that game of life on a cube was with flip dot displays, but they are way too expensive.
They're very expensive, but they're also probably going to be noisier than your 50 hertz hum on your clock.
Yeah, but okay, if I had some flip dots, it would be somewhere outside of the house, because it would also be very, very big.
Yeah, true. Very true. But this thing is awesome. You have a video on the Hackaday article, and you see it running, and this thing is very cool. Do you have it on more often than the clock? Like, do you have it on just because you feel like watching it move, or is this one of those things where you've seen it so much during the process of building it that now you just turn it on for special occasions?
Currently it sits right beside the TV set, and it's on. Yeah, it's like looking at the fireplace. You can watch it every time.
Yeah, for sure. There is a pattern. I don't know if you know about WLED. It's a piece of software that runs on ESP that handles NeoPixels and has built-in patterns. But there's a few of those patterns that are not game of life, but like game of life like the LEDs have some sort of random sort of pop in and pop out, and that gives you a little bit like the fireplace aspect too. So I completely understand where you're coming from with that.
And it's always nice to watch. And it's one big thing, it's silent.
Yeah, compared to the clock. So, is this something that someone like me can go and build myself? Like, do you provide the files, or is just kind of like take a look at the project and enjoy it? It's not really meant for anyone else to replicate.
I will upload all files, all the schematics, and also my mistakes I made in the schematics.
Well, I mean, that's kind of par for the course.
Yeah. You see, I switched the order of the rows on the PCBs I developed because I did not read the fine manual correct.
Uh-oh.
But it was possible simply by a bit rotation in the software to make it correct.
Did you is the green PCB solder mask, was that a choice you made for the style, so it looks like a classic PCB, or is that essentially something because it was cheaper and you could get it faster?
It was default. It's not cheaper, it's not more expensive, it's just default.
Gotcha.
And for me, PCBs are green. Yeah.
Yeah, fair enough. I mean, classical PCB color. Because I think having a cube like this in black with white LEDs, or potentially in white with either a red or a blue LED would be really, really striking. But I can see that you picked the red LEDs and the green PCB, and it does seem to work together. So it looks pretty good.
Yeah, I also thought about putting red glass over each of the PCBs so that only the red light goes through, but I decided to do it not.
Yeah, that's going to be complicated with mounting the red, the red lenses, because already your cube has sort of like 3 different internal structures, right? There's a brass cross with a 3D printed, circle in the middle. Then you've got the brackets, and then on that is the PCBs. Then you'd have to find some other way to mount the either the glass or the acrylic on top. That starts to get compounding complexity, that's for sure.
So I'm quite happy with that, and yeah, but it has to be finished. It has to be made that there are no gaps between on the edges. Then I'm happy with it.
I mean, I think it looks phenomenal now, and I can't wait to see the final product. Are you going to post that onto Hackaday as well?
Yeah. I also I started the final documentation on my computer here in the simple Word document, and then I will move it up to Hackaday if it's finished.
That is
also with my fails and things I made wrong.
I mean, that's all part of the learning process. And honestly, I never put out anything that's perfect. So I'm with you. What's nice about developing stuff for open source is, since in my case, I open source everything. So if people find that I made egregious errors, I just tell them, you can fix it because it's open source. So make it the way you want it, right? That's my theory, at least.
And others can learn about it.
100%.
Learn from it. Read the fine manual, for example.
So once this cube is done, what's next for you? Do you already have sort of like a pool of ideas in your head, or you're just going to let inspiration hit you?
I think I let inspiration hit me with some other things. But next project, I have a pre-World War II telephone that has to be restored to a nice looking telephone. Yeah.
Very cool. And are you going to continue to post on Hackaday?
Not that telephone, because it's only some paint and that's it.
Okay. Because you can always put a ESP32S3 and use I2S to pipe some audio through the headpiece, or the handpiece the earpiece when you disconnect the phone. Then you can post it on Hackaday.
But that phone will be brought back to life originally. I can connect it here to my telephone system here, and I could use it. I still have a landline here.
Oh boy. Now you're showing your age.
You see, if you have your internet connection, you always have some landline. It's I don't know if you know, in Canada, the Fritzbox from you can still connect a normal old telephone that can do pulse dialing, and the Fritzbox, this router, knows how to handle it.
Oh, interesting.
And then the rest is voice over IP, normal.
Yeah, that makes sense. Yeah, I know nothing about landlines here. I mean, I have fiber internet, like fiber to the home, which is I'm very lucky to have, because Canada is a giant place and not everywhere can have fiber to the home. But yeah, we bought this house in 2012, and we never had a landline. I mean, there's landlines going to the house, we're just not in service.
Not a real landline. It's a cable. It's a coax cable coming in. Also television. It was a television cable at first and moved on to internet connection.
There we go. So tell me then, aside from electronics, like what is your formal education in? Because I'm sure a lot of people are probably listening to this, and if they've gone to see the Hackaday articles, they can see the complexity in which your designs have. So what qualifies you to make these things? Did you study mechanical engineering, electrical engineering, anything like that in school?
No. I studied sometimes physics, but never made a graduation in physics because of personal problems. And I got a normal education. In Germany, it's called an Industrietechnologe. And then I started consulting for IT security and kept consulting for IT security, firewalls, penetration testing, then project management and electronics and all I did here, I learned by myself.
So very
because I wanted
iterative.
Yeah.
Which is really cool. I mean, it gives people like me hope. Like, I've never designed anything nearly as complicated as what you have going on here. And so all the people out there that don't have a formal education, just sheer force of will, probably mixed with some good intelligence stats, you can get some really cool projects made. So that's really good to hear.
Yeah, just try it. And if you fail, try it again. And if it fails, try it again sometimes. And then you find a way that it's working.
So I've got a question that I ask every single one of my guests. Can I ask you that question now?
Yep.
So let's say you get a grant. So just think of unlimited money, but you have to, start the business of your dreams. Now, it doesn't have to be profitable because you're getting money for it, but it does have to provide either a product or a service. What kind of business would you start?
I want to be an artist and build these things in perfect shapes. Build sculptures that stand, somewhere on places and have blinking lights on it.
So you'd be some sort of like electronics artist, like you kind of are already, but you'd have some sort of display space, or you'd be commissioned to do these things and put them out in public.
Yeah,
which is really cool.
Something with lasers. That would be also some kind of thing. Yeah.
Yeah, maybe you could be the first to develop an actual lightsaber.
Not possible.
Hey, it's fantasy. We can imagine.
Yeah.
One of my ex-guests here on the podcast, friend of the show, Steph Piper, she sort of achieved what you're aiming for here. So she made, I believe the project was called the Party Button or the Party Crosswalk or something. In Australia, they have crosswalks. So you press the button and then the traffic lights change and then you can walk across. Well, they're crosswalk button, masts, I guess. They have a certain shape, and she got a hold of one, and then when you press the button, it would like play music instead of just like making an auditory tone to count down. And she actually had to modify her design of this so that it can be put out in public without it falling over and hurting someone if someone smashed into it or something. So she's essentially done what you would aspire to do if you had some unlimited money. So, I mean, it is possible. It would be really cool to go visit your hometown and there'd be a hill somewhere with a giant Game of Life cube, sitting there with millions of LEDs going off. That'd be awesome.
That would be really awesome, yeah. But I can't imagine who would solder that LEDs.
You would have to. You'd be paid, right? So you'd have unlimited money. So you'd be paid like $100 an hour to do them panel by panel by panel.
That would be interesting. How much max these controllers can be daisy chained? I never tried it. I'm at 24. It works.
It's crazy to think that the scalability, I think in the end, will just be limited by your trace length. At some point, your muxing has to reach another target. Maybe at that point it'll have to be like wireless communications, or maybe there'll have to be like a cluster of like Ethernet communicated microcontrollers, with a switch in between. When you start scaling things up, stuff goes a little crazy.
Yeah. Then I would go for each of these panels is separately addressable and run on its own.
And you're going to need like a Ryzen 9 9950 to run the Game of Life, because there'll be like millions of LEDs.
Yeah, but I'm comfortable with my small version that sits in my living room and blinks there for now.
I have to say, once the design files are out, if my 3D printers here can handle it, I'm pretty sure I'm going to be building my own version and dedicating it to you, because this is it's a really cool project, and it makes me excited to see what might be next coming out of your workshop.
I don't know what comes next out of my workshop, to be honest. I simply do not know.
So we're just at the end of the podcast now. Is there anything you want to leave the viewers with? Is there like a message you want to pass them, or something you want to encourage them to try, or anything like that?
What I said before, try what you have in mind, and if it does not work, try it again.
Absolutely. Like someone like me, like I have no technical skills in, KiCad or Fusion 360, all the software I use. I am an iterative designer. So I design, I 3D print my object, take measurements again if it's wrong, and then iterate on it. So I would agree with you. I think you've got the right idea. Try and try again.
Yeah, and on the iterative design, I also have at least 2 rounds until it works. If you look at that cube support structure in the back.
Yeah, it looks very different, because I'm looking at, you have a post from the 7th of this month, and the internal structure looks different than the one that you show off. So I don't know if that was an earlier or a later version.
The first one was an earlier version, and it simply did not work. The second one with the brass tube in the middle is that one that works.
Gotcha. Because the one on 07/07/2025 has like just flat planes with corner brackets, almost like angled brackets on the inside.
Yeah, and that did not work.
Well, you gotta do it to find out. Well, thank you so much for taking time out of your busy schedule to be onto the podcast. Tell the people where they can reach out to you. Let's say they want to tell you how much they appreciate your projects or your podcast appearance. Where can they reach out to you?
The simplest thing is at Hackaday. I have there my profile, and you can talk to me, because on the other channels I have only private communication.
Sounds like a very sane thing for a pen tester to do.
Yeah.
Also, I was a little surprised that you have Home Assistant stuff going on as a pen tester. I guess it's a pretty safe protocol then.
The Home Assistant is running here on premise on my own server, not in the cloud.
Gotcha. All right. Well, thank you so much for being on the podcast. And me as well as most of the viewers listening here, I'm sure are waiting with bated breath to see the final iteration of the cube. And I hope it all goes well and you get your tolerances down as far as you wanted them.
Yeah, I think I can get it. Yeah, and thank you for being here. It was a pleasure. It was fun.
And for the listeners, I want you to go down in the description or the show notes wherever you're listening. I'll put all the links to the projects in there, and so I'll link Chris's GitHub as well. And I hope I'll catch you guys on the next podcast. Thanks for listening, everyone.